Okay, so this is the Chapter 2 through 3 test review. I'm just going to walk you through each of the problems and the logic that we use to answer them. And hopefully as we go through this, you'll be able to get the support that you need. If not, reach out to me on Teams or see me in class and get the help that you need. But first two questions are really about whether something's a function or not. In the first problem, we have the ordered pairs 3, 7, 6, 4, 2, 5, 4, 6, 5, 4, and 1, 2. And we're being asked, is it a function or not, and why? So the first thing we need to understand is that a function is a function if, and only if, for every x, or input, there exists at most one output. So that means if we pick an x, there can't be two different y values associated with that x. So what we're going to do is we're just going to come in here real quick. We're going to look at 3. Does 3 occur anywhere else as an x value? The answer is no. That means that when I pick x as an x to be 3, the only option is 7. That's a good thing. That's a yes for the function so far. Now I look at the 6. Does 6 occur as an x value anywhere else? Here it's a y value, but not an x value. That's fine. I just have to make sure, hold on. Just got to make sure that I don't have my x's being repeated, and so far I don't. Then I go to the next value. I have a 2. Looking again at my list, I don't see a 2 being repeated. So that means that 2 only produces a 5. I'm good to go. Then I've got a 4. I've seen a lot of 4s in here, but none of them are x's. So the only x that's 4 gives me a value of 6. That's fine. I don't really care what it gives me as long as there's only one of them. If there were 2 of the same x value, we would talk about what the y's produce. There's a 5, that's unique, and a 1, that's unique. So just by comparing these at this point, I know this is a function. So I'd say yes, each x has only one y. Something like that. Okay. For instance, if I added, say, the point 2, 3, we would notice that this 2 says it should give me 3, but this 2 says it should give me 5. That would be an example of a non-function. So that would have to, if that was there, I would say it's not a function because 2 gives me 2 different choices. The other thing that could happen is you could end up with an identical point. Does 2 give me 5? Both times it's the same y, which means it's just repetition. I haven't actually done anything unique or new. So that would still be a function. Okay? Question number 2 is built around the idea of the vertical line test. I call it the VLT. Okay, vertical line test. And the graph looks something like this. Okay? Vertical line test tells me that if I draw a vertical line, okay, straight up and down, and then I move that vertical line from left to right, if the vertical line ever touches my curve more than once, I would say it's not a function. So you see how it's crossing right here and right down here? That's an issue. And because it crosses more than once, because it crosses there and there, we would say that it fails the vertical line test, so it's not a function. If it passed the vertical line test, say for instance you were looking at a graph like this, well, a vertical line is never going to touch this graph more than once, so it would pass the vertical line test. Okay, so this is a pass. This one here is, we can see those examples of a failing the vertical line test. Over here, the vertical line test would just have the one dot where it crosses. So that's passing, okay? So the first two questions, we're talking about vertical line test and ordered pairs and looking for if something's a function or not. All right, let's take a look at the next type of problem. So number 3 and 4 are both about finding slope. Whoops, come back there. Number 3, we have the ordered pairs 1, 3, and the ordered pair 3, 4. And on number 4, we have the ordered pairs 5, 6, and 5, negative 2. All right, so here, remember the slope is y2 minus y1 over x2 minus x1. So on this problem, I take my y2, which is 4, minus my y1, which is 3, over my x2, which is 3, minus my x1, which is 1. And if I simplify these, 4 minus 3 is 1, 3 minus 1 is 2, and my slope is 1/2. Over here I do the same thing. There's my y2. So I start with negative 2 minus, I'll go m equals, minus my y1, which is 6, over x2, which is 5, minus x1, which is 5, and I end up with negative 8 over 0. Now, there are two different scenarios where this can happen. I can end up with 0 on top, or I can end up with 0 on bottom. If 0 is on top, it's just 0, and you can put that in your calculator and get 0, and there's nothing special about it. But when we have a 0 in the denominator, this means that it is undefined. The slope is undefined because the line is vertical. So the answer to a question like that would just simply be undefined. That doesn't mean that on the test you're going to get an undefined answer. In the test review, we try to represent all the different options that could come up so that you're aware of them before you take your test. Okay? The formula, the slope formula, if you need it on the day of the test, I'll certainly give it to you. It's not something that I think is a big secret. So if you need that the day of, yeah, just let me know. Question number 5 takes this idea of slope and wants us to go a step further with it. It wants us to actually build the equation of a line. So we want the slope to be 1/2, and we want it to pass through the point 4, 3. Okay? So there is a formula for this, and there's actually two approaches. I'm going to go through both approaches, and you can choose which one you want. There's the standard point-slope form of the equation, which is y minus y1 equals m times x minus x1. And if we go through and build this, it'd be y minus, take your y value, 3, equals my slope of 1/2 times x minus my x value of 4. At this point, we just need to clean it up by distribution and isolating the y. If we distribute, we get y minus 3 equals 1/2 x minus half of 4 is 2. And now I just add 3 over to produce y equals 1/2 x plus 1. Okay? There is another way to do it. It's not necessarily easier or harder. It's just a decision you make. It's to take y equals mx plus b and solve for b. That's the thing that we don't actually know. We don't know the y-intercept. We could put in a y value of 3 equals a slope of 1/2 times x being 4. So we're still using the same ordered pair and point plus my unknown b. Well, half of 4 is 2, so I'm going to minus 2 from both sides. And that gives me that 1 is equal to my b. Well, in this format, y equals m 1/2 x plus my b, which we learned was 1. And you can see we got the same answer in both cases, so either one of those is a workable option for number 5. All right, so we turn the page if you've got your test deal out in front of you, test review. And number 6 and 7 are both about the absolute value graph and how we graph it, but then also how we build an equation from a graph. So on question number 6, we're given the equation y equals negative 1/2 absolute value of x plus 2 minus 5. All right. First thing that I always want to find is the slope of the right-hand side. So slope of the right-hand side, which is always this number right here, negative 1/2. And I also want the vertex. The vertex here is negative 2 and negative 5. Remember, when you're taking the vertex, we always switch. Because it's grouped with x, we switch that sign no matter what. So if it's a negative 2, we use plus 2. If it's plus 2, we use negative 2. And this one we keep. Okay? We keep that sign the way it is. If it's positive, it's positive. If it's negative, it's negative. So that much information, we should be able to go and create a pretty crude graph right now. 1, 2 to the left, 1, 2, 3, 4, 5 down. Gives us a dot right about there. And then I use the slope on the right-hand side, which tells me to go down 1, okay, and over 2. 1, 2. That would put me right on the y-axis there. And I would know that that graph is going to go down like that to the right. I need to do the same thing the other direction. Go down 1, go over 1, 2. And then from there, I can also graph that down. So there's our basic graph using our vertex and our slope. Remember, switch the sign of the thing with x and keep the other value the same. Number 7 asks us to do this in reverse. It gives us a graph, okay, with a dot here at 2, 1, and a dot here at 4, 2. Okay? And so what we want to do is start by finding the two things we need. We need the vertex, which will just be this 2, 1, that point right at the V. And the second thing we need is the slope. To find the slope, on the grid that I give you in the picture, it's actually pretty easy to count. But you got to figure out how much are you going up. Well, from 1 to 2, I go up 1. And from 2 to 4, I go over 2. So my slope on my right-hand side is 1/2. This means my equation should be y equals 1/2 absolute value x. Now I've got to put the 2 in and I've got to put the 1 in. Where people sometimes can get mixed up is what's the sign of each. Now remember, like we set up here, you switch the sign of the thing that's going to be grouped with x. And since it's a positive 2, I better put a negative 2 here. And we keep this one the way it is, and since it's a positive 1, we'll put plus 1. Okay. So we've made it through question 7. We're 70% of the way done with the test. And hopefully these are still seeming pretty straightforward. If you're having questions, again, chat with Mr. Welch when you come into class, and we try to answer some stuff and clean some stuff up. Number 8, you know what, let's clean this page up a little bit. Yeah, it's a good time to clean the page. All right. So we get to question 8, 9, 10, and even the bonus question. They're all about solving a linear system. Now, I want you to understand, all of these can be solved by any of the methods. However, each of them asks for a specific method, and you need to use that method to get full credit. Each of these questions will be probably worth about 4 points. 2 points for your x, or 1 point for your x, 1 point for your y, and then the rest of the points are coming from, did you use the correct method? So it's important that you show you're able to do all of those. So number 8, we have the equations 3x plus y equals 2, and y equals 2x minus 3. To graph these, which is the method we're being asked to do, we can graph them by hand. It's actually a pretty good grid there that you could use, but you're also welcome to use it in a graphing calculator. Either way, it's kind of nice to have these in y equals format. To get this one here to be a y equals, I need to minus the 3x. So this becomes y equals negative 3x plus 2. And of course I have y equals 2x minus 3. Now I know enough to know how to graph these, but I'm going to go down to negative 3, put a dot, and I'm supposed to go up 2 over 1 to put another dot there, and then I'm going to get this graph going like that. This other graph starts at positive 2. Put a dot. Then I'm supposed to go down 3 over 1. It's down 1, 2, 3 over 1. And there's my graph. Oops. By hand. So I didn't do a very good job graphing that by hand. It's a representative graph, though. Please use a straight edge on the test just to make it look good. But I did find the answer was right here at 1, negative 1. Now here's the deal. That's not the most efficient way. That's probably not even the best way to go through and find that. It's not too slow if you're really comfortable with the graphs, but I'm actually going to grab my graphing calculator real quick, go to my y equals, and let's graph these two in our y equals. We've got a negative 3x plus 2, and we have a 2x minus 3. And if we graph those, again, you'd have to get this representative graph down on a paper, so be careful, make sure it looks reasonable. One option is to go to the table, second graph, and just find x's and y's. If you notice right here, down here at 1, the two y values are both negative 1. But you could go and plot points for each of these lines, like 2, negative 4, or 2, 1. Get your two graphs drawn that way. And so you can find the answer in the xy table. if you can find the matching y values. If for some reason you can't find it, or you don't even want to go through that process of searching, the other option is go second and trace. And the option you're looking for, excuse me, the option you're looking for is an intersection. If we choose number 5, then we're just going through, yeah, it's the first curve, yeah, it's the second curve, yes, I want you to guess, and it'll come up with our 1, -1. But remember, you have to give me the representative graph that you're seeing on your calculator. You can't just give me the answers. Okay? So that's number 8. 9 and 10, you could do the same way. You could graph both of them and find the answers that way. But to get full credit, at some point you have to show me the algebra that goes with it. So number 9 has the equations 2x minus 3y equals -4 and 3x plus y equals 16. And we're asked to use substitution. Now substitution is the one where we get one of the variables alone. And if we look for our lonely variable, that would be this y here. So I'm going to minus 3x. So now y equals 16 minus 3x. And if I put parentheses around that, that can go into the other equation for y, giving me 2x minus 3 times 16 minus 3y equals -4. The algebra we're going to go through right now, it's not complicated, but you've got to be careful about signs and about combining like terms. I'm going to go ahead and distribute. I'll still have my 2x, but now it's minus 48. And this is really important. A -3 times a -3y is a positive 9y equals -4. I'm going to go ahead and move my 48 over to the other side by addition. And then I've got my 2x and my 9y that need to combine to make 11y equals 44. Of course, if we divide by 11, y is 4. To find my x, I need to plug that information in. Whoops, that's an x. Those are x's. My bad. If you caught that, good for you. I need to plug that in for my x to find my y. That's over here. So now y equals 16 minus 3 times my x, which is 4. I'm going to make that x a little bit bigger. All right. 3 times 4 is 12, and 16 minus 12 tells me that y will be 4. So my final answer is 4, 4. All right. Number 10. Last regular problem before we hit the bonus. We have 4x minus 3y equals 10. All right, this is number 10. And we have 8x minus 6y equals 20. All right. So in this problem, we want to try and pick one of the two variables to eliminate. Whether that's x or y, it doesn't really matter. I see the 4 and 8. I really could just turn this 4 into a -8 if I multiplied by -2 and distribute. Okay? This would become -8x plus 6y equals -20. If I bring the other equation over, it's already got 8x. That's going to cancel. Minus 6y equals 20. As I go to cancel, the 8x's cancel. But so do the y's. This is me showing you the what ifs. Okay? When both of these cancel like this, we get 0 on the left side. Now the question is, do we get 0 on the right? -20 plus 20 is 0. When we have a statement like this, 0 equals 0, that's a true statement. Because it's a true statement, we're going to say that this is infinitely many solutions. These lines are identical. Normally, you'll end up with something where the x's cancel but the y's don't. Let's say you ended up with, you had 6x and or 6y and minus 5y equals 10 equals 3. You'd add these and get y equals 13. And then once you know y is 13, you could plug it back in to find x. If you have questions about that, the specifics, gladly go through that with you individually if you have those questions. Okay, last type of problem. Okay, last problem that we've got to deal with is our 3.4, our bonus question. It's all about solving a 3 by 3 system. This isn't that challenging, but it is something that takes steps. It takes time for us to get through. Okay. Question number, the bonus has 6x plus y minus z equals -2. We got x plus 6y plus 3z equals 23, and -x plus y plus 2z equals 5. We're going to name these equation 1, 2, and 3, and our goal is to go about trying to combine the two equations to work our way down and cancel stuff out. Okay, we're going to pick a variable that we think is easy to remove. The z's aren't too bad. The y's, you got a y and a y. That's not too bad. I like these x's because I see that 2 and 3 right here, this x and -x, they're going to cancel right away. That's my first combo. Let's put 2 and 3 together. I don't have to do anything to get the x's to cancel because they'll do that naturally. So x plus 6y plus 3z equals 23, and -x plus y plus 2z equals 5. If I add these together, the x's cancel. 6 plus 1 is 7y. 3 plus 2 is a positive 5z equals 23 plus 5 is 28. This I'm going to call equation number 4. The next thing I'm going to do is look for a combo where I can still cancel x. I've got to stick with x, but I can't use 2 and 3 together anymore. But 3 and 1, notice one of them is already negative. That's good for me in terms of my substitution. So I'm going to take equation 1 the way it is. 6x plus y minus z equals -2. But equation number 3 doesn't work the way it is. I'm going to have to times this by 6 in order to get a -6x. But I'll also get a positive 6y, a positive 12z, and it will equal 30. When I go ahead and add these like terms, okay, I'm going to get my x's to cancel. I'll have a 7y plus, it looks like 11z equals 28. This would be equation number 5. Now, when I look at 4 and 5, I notice they both have y, they both have z, and I should be able to cancel one of those. If I look closely, I see that the y's both have a 7. That makes them prime for cancellation, okay? So we're going to take 4, and we're going to take 5, and it doesn't really matter which one we're going to turn into a negative, but one of them's got to be negative. So I'll turn the top one into a negative. I'm going to multiply this by -1, okay? And it's going to produce a -7y minus 5z equals -28. My bottom equation I'm not going to touch. It's going to be fine. 7y plus 11z equals 28. As I combine these, my y's cancel. Then I've got -5z plus 11z is 6z, and that equals, 0. Now some people will stop right here and say there's no solution because 6 doesn't equal 0. But we still have a z here. If we divide by 6, z turns out to be 0. So I actually do have an answer for this problem. Z is 0. But now I need x and I need y. The good news is I don't have to do this all over again. I just need to plug this into one of these problems here, 4 or 5. Either one would work. And then take the two answers and plug that information into one of the originals. So let's just take number 5 here. Equation number 5 would be 7y plus 11 times 0 equals 28. 11 times 0 is 0. That stuff's gone. All I have left to do is divide by 7 and get y equals 4. So I've got y is 4, I've got z is 0. If I come back up to the top, I actually like equation number 2 the best because you notice it's a single x all by itself. So x plus 6 times 4 plus 3 times 0 equals 23. Well, 3 times 0 is 0. 6 times 4 is 24. If I minus 24, then I get x equals -1, giving me a final answer of -1, 4, 0. There we go. So that's what your test has on it. Obviously, that bonus question is going to take a little bit of time, but I promise you, you're going to have like 30 minutes in class to spend on the one question. Take the time, make a good effort, and you'll be rewarded for it if you make the effort and you make it clean. Okay? Good luck, and we'll see you in class.